you for joining us today. So I'll just tell the students a little bit about who you are. So Nicole is currently the VP of Research and Strategy at GitHub, and she is a world expert and leader in the Devops movement in software engineering. And she founded DORA, which stands for DevOps Research and Assessment. And she is the lead investigator of the State of DevOps report and also the lead author of Accelerate, which I have read her book a couple of times, which is a book on the science of lean software and DevOps, a really great book. Before GitHub, she was at Google after they acquired DORA, I believe, and she has been a professor, a hardware performance analyst, and a developer and programmer. She has a PhD in management information systems and cognitive science from the University of Arizona. And she's also a big fan of Diet Coke, and she's super funny on Twitter, so you should follow her there. So Nicole,
you guys are going to see all my shit posting.
Love it. We have to laugh more. We have so much going on in the world today that we need all the laughter and joy we can get, right? So it's my pleasure to introduce you today to the class. And in preparation for the class today, we did watch your talk from the DevOps Enterprise Summit in 2017, which I can tell everybody really enjoyed immensely. It's a great talk. And so I'm going to start off with a couple of questions, and then we'll switch over to the students.
Can I do can I slide in a mini story?
Yes.
My little origin story is I was a developer for IBM for a little bit and a sysadmin. And while I was in grad school, I was also working full time, never do this, and stumbled onto some of Evan and his team's work and decided to, so at the time I was studying deception detection, large group software, NLP and ML, because that's what I was doing because I was in logs all day long. And as a random side, decided to do a usability study. Flew myself out to Research Triangle Park, RTP, did a usability study with a bunch of sysadmins on dummy software, and a handful of them kept saying, oh, but I won't do this because it's going to be too risky. And so that study prompted me within a week to completely shift my entire dissertation off of NLP deception detection into what we now call DevOps, which I realize that sounds really obnoxious. I'm the original hipster. But it was individual and team performance measures to predict outcomes based on system and information characteristics. And one of my early studies, Evan's team had kind of finished up what they were doing at Almaden, and the team at Watson was like kind of panicking, and they were like, oh my gosh, we need someone to study sysadmins. Nicole, you're the expert, you can come do it. And I was like, what? So I flew out there and I did ethnographic studies for a week or two as a piece of my dissertation. And it was amazing and fantastic. And so I ended up doing kind of like ethnographic pieces and also empirical pieces for that work. So thanks, Evan. It was amazing to see. And his piece about verification information, I actually had like one of my early papers was about how verification information was so important for sysadmins and people working in complex distributed systems, because they have to be able to see what had just happened, and people writing GUI systems for sysadmins and developers working in complex systems were just giving like a confirmation screen. And I kept finding sysadmins saying, okay, now I just need to log into the system to make sure that happened. Wow. And we presented the findings to IBM, and they were like, but we're using UCD guidelines, user-centered design guidelines. And at the time we realized, or at least in the division I was in, and I was doing hardware performance for high-end storage disk. That group used the exact same one set of UCD guidelines for end users using Lenovo laptops as they used for high-end like sysadmins running high-end storage systems. And I was like, so I'm switching. And like, wow. It's been fascinating because that one chance encounter, like one or two random back channel conversations with Evan and a few people on his team, and that one usability study like totally changed my entire career.
which I think is a great lesson to share, right, with the students here and with all of us, right? That, you know, these chance things can totally change what we look at, and they're good. It's good that it does, right? And, you know, one of the things they're doing in this class is reading all of these papers that aren't necessarily in their area. And I'm saying to them, you know, see it as an opportunity, right, to learn something new, because, and, you know, this is a great story of this. So it's great to have you and Evan in the same call. So the students actually have asked some great questions, and I can probably talk to you later with the questions that I have. I think I'm going to pivot to their questions and let them jump in, and let's have a discussion. So I'm going to go in order again, folks. So Alessandra, would you like to jump in with your question?
Yes. Hello. My question, I was exploring the Dora's research program page, and my question is more related to the methodology. So I saw there an information related to our research use behavioral science to identify the most effective and efficient ways to develop and deliver software. So I got curious, how did you use behavioral science in this context? So a so technical context.
Yeah, that's a fantastic question. So it's really interesting because, as I mentioned, when I first started my PhD, I was focusing on things closer to semantic modeling, NLP, log analysis. But then when I pivoted and I wanted to start studying and understanding how to understand and predict software development and delivery performance, that's a really, really complex problem. It's a really complex question. So how are you going to measure and understand the success and the performance and the outcomes of software delivery? So that's going to be things like coding, which, by the way, is like one set of processes which behave one way. It's a creative process, it's problem solving, it has a certain set of characteristics. And then developers check in code, and then it goes through another set of processes through a pipeline, which is like build, test, maybe QA, and then like release engineering and ship, and then it's live. When you start thinking about all of that in a complex distributed system, a startup is maybe one thing, but once you pass startup stage and you're in an SMB or an enterprise, this is non-trivial. And by non-trivial, I mean it's a shit show. This is so, so hard. Even today, if you're talking to an organization of any size, if you want to instrument a system to collect telemetry data, it will take you at best 2 years, if not 4 years or more, to instrument the entire set of data. So what are you going to do instead? You're going to pivot and you're going to say, okay, I'm going to ask questions. And then everyone's like, oh, questions are sorry, I swear a little bit. I'll be nicer. We're in college. Questions are fake. Everyone's lying. Okay, so then what can you do? You can ask psychometrically rigorous, reliable questions. And so then what you need to do is you need to start breaking it down into composite measurable pieces. Because then, so like ethnographies are very, very important, but they're limited in certain ways. And so now if we want to start measuring and calculating and comparing with metrics, okay, another way to do metrics is surveys, right? So then we said, okay, well, let's focus on the comparable, repeatable, engineered part. That's the pipeline. Okay, then, like I said, you've got build, test, CI/CD, automated test. There's a bunch of theory that says this is probably a thing. Okay, how can we measure it? And like, what's the definition? What are the measures? And from that comes from behavioral research. It turns out people hadn't really done this often enough before. So we kind of had to start from scratch and build from there. But that's what we mean when we say behavioral methods and why we did it that way.
Great. Alessandra, does that answer your question?
Yes, thank you very much.
Great. We'll switch topic a little bit and go to Jonathan Park's question, which is more focused around understanding the high, medium, low performers. Jonathan, are you there?
Yeah.
Great.
Yeah, so my question was, when you talked about the high, medium, and low performers in your presentation, you talked about how the high performers didn't actually need to make trade-offs at all. But I was wondering if you looked into the actual companies that you were reviewing's like kind of value in terms of how much they can afford to pay their teams and whatnot? Because obviously smaller companies aren't going to be able to pay their engineers as much money. And from my experience, the senior DevOps engineers get paid quite well. And so I would imagine that the big teams of DevOps engineers at big companies like Google are going to cost quite a lot of money to hire. Is there any of this that you took into account when you were looking at the difference between the performers?
So there are a few things packed in that question. First is, when I say there are no trade-offs at high performers, there's actually no trade-offs anywhere. Sometimes I position it as there's no trade-offs at high performers. There's no trade-offs at low performers either. So 6 years of data show that speed and stability don't trade off. So when you're doing really well, you're doing really well at everything. When you're a low performer, you suck at all of it. So it's actually really interesting. It happens to follow theoretically with economic order quantity. So that's sort of interesting. In terms of pay, I think this is the second thing that's hidden and embedded in there in really interesting ways. We hear this argument from many companies. Smaller companies say, I think I suck at this because large organizations can pay people more. This isn't my fault. I don't have the money to be paying people. Large organizations say, I suck at this because smaller organizations have less complexity, and so they don't have as many problems to deal with. So either way, you're kind of fighting against something different. To your point about paying and how senior DevOps engineers get paid more, that's something else that's kind of different. Pay is another thing. Seniors tend to get paid more. DevOps engineers also tend to get paid more. There's a whole other like side rant and Twitter war happening around like, should you have DevOps in your title? Yes or no, whatever. We do tend to see in the data going back several years that once you add if you magically add DevOps to your title on LinkedIn, your pay goes up significantly. So whether that matters or not, who knows, who cares, but own it, add DevOps to your title and like get paid. So I think there were a lot of things packed in that question. Did I answer it?
Yeah, I think that's a pretty good job.
Okay.
Great. Thanks, Jonathan. Good question.
Hopefully we are all now DevOps professionals and get paid more money.
Yeah, I bet that this conversation is going to be changing maybe some of the roles that people were going to look for after they graduate. About half of the class are senior undergrads, so this is their last term, and maybe going to look for jobs right next term. So I'll ask them later if this had any impact. Nimi, are you there today? Because I like your question. Yeah.
Okay.
I like your question. I mean, I like all of them. Yours is next.
Yeah, I just want to like how high-performing teams try to mitigate the risk of like disruptive technologies.
Say that last part.
I would like to know like how these high-performing teams trying to mitigate the risk of disruptive technologies.
How they mitigate the risk of disruptive technologies. I think everyone has to mitigate the risk equally. I think high-performing teams do a better job of it in the fact that they can ship software better and faster. And by that, I mean they can ship features better and faster, they can ship patches better and faster, they can respond to security threats, they can deal with anything better and faster. And if it's disruptive to their technology and their consumer base, then they can respond strategically better. So high performance is basically, it's just a statistical clustering algorithm. So it just categorizes you based on how fast and how stably you can ship software. Can you do it daily or on demand? Are you doing it weekly? Are you doing it monthly? Are you doing it 6 months or less? So based on that, can you make strategic decisions and ship whenever you want? Or do you make strategic decisions and then you basically sit and wait in a queue and you maybe get the features that you want out to market in 6 months? Or you desperately need a security patch and you sit and wait for that security patch to make it out in 6 months and you desperately pray that you don't get hacked. right? And so that's kind of what that high performance means, is you have the ability, what do you do with it as a business technologist and as a business strategist?
Thank you.
Does that answer your question? Yeah.
Thanks, Mimi. The next couple of questions are actually a little related, Anthony and Jordan. Anthony, do you want to jump in?
Sure. Hi. So in your presentation, you mentioned that DevOps is difficult, is hard. And from my very limited experience of DevOps, so because I did like 4 months of DevOps jobs on my last co-op job, I felt like DevOps is indeed very hard. For me, it was mainly about the technologies because it covers like a wide range of technologies. So in your from your perspective, what do you think makes DevOps difficult? Is that the technology or like communication between people with different roles, or is it company's culture?
That's a great question. And honestly, I think the thing that makes DevOps hard is that it's holistic. It's that it's everything. So the way that we used to do technology and the way that many organizational executives want to think about doing the tech, doing the DevOps, doing the whatever their magic word is, right? Whatever their board hands them, whatever they put on the slide decks, find and replace. The thing that used to get techs a bonus, big fat bonus check, gold star on the forehead, was like doing the next hotness and being done. And you could deliver in 1 or 2 quarters, at least a year, you were done. Technology does not work that way anymore. It's not even close. And people who think DevOps are tech, they're effed. Like, it is not the way it happens at all. And people who focus only on technology are in for a world of hurt, because you can implement technology, and technology is difficult, particularly because now we are working in complex distributed systems, especially now complex distributed systems like monoliths are a little different. They're so complex, they're hard. I started my career in mainframes, so like it's so hard, but it's not complex distributed where like you screw something up and the domino effect can still like bite you a week later. But now we need to be building complex tech across teams with like good communication. The culture is foundationally important because our technologies are so complex that no one person can hold it all in their head. So you have to have this shared understanding, and your process fundamentally has to change, right? So everything has to be done together, and that's what makes it so difficult. Like, so to kind of pull that back around, you can't have an exec come in and just like swap one piece out and have something work in 6 months. It's usually a multi-year process, at least 2.5 years, and it's holistic and it's difficult.
Okay, thank you.
Yeah.
I think in a way you touched on Jordan's question, but I'll let Jordan jump in and see if she wants to kind of ask it anyway or something different. Are you there, Jordan?
Yes, I'm here.
You touched on it already, but yeah.
Yeah, I mean, my question was, what do you think are the most important changes companies can make in their software? And as a side note to that is, how can we encourage this change?
That is a great question. It can be a little tricky, and usually the answer is it depends, right? And so what an organization needs to do is take a look at where, kind of like take stock and baseline where they are right now. So understand like how well they're shipping, how well they're delivering, and how it's impacting their goals, right? Their feature delivery or like value delivery, if they're kind of a for-profit, or if they're not for profit, how is it affecting their serving their constituents? Like, how is it affecting their reason for existing? If they don't know why they exist, like they have bigger problems. At that point, understand and identify what your core bottlenecks are, right? What is the thing slowing you down? What are your biggest constraints? Sometimes your biggest constraint is a change approval process, right? Sometimes it's honestly just about bureaucracy and paperwork. And there have been times I've stepped into organizations, and they had no idea that was the problem. And it's several weeks of bloat. And it's not about technology. It's all about process. It's usually kind of a combination of the two, but many times that's what it is. Or it's a technology thing, but it's a technology thing housed in something else, where you need to provision resources to get developers need to be able to provision a development environment, and then they need to be able to provision a testing environment. And it's the provisioning that takes weeks. Like technically, I'm going to double load a word, right? Like officially that's a technology problem, but really it's the provisioning piece that's locking you up for like weeks at a time, and then weeks at a time. You just lost 2 months getting a dev environment for your new thing and a test environment for your new thing. Fix it. Just fix it. It doesn't matter. Right? And many times that's also where being on the cloud helps, because you can provision things automatically very quickly. And once you get that fixed, you can provision something like anywhere really, really quickly. Spin it up, spin it down, you're done and go. Does that help? And I'm sorry, like that's an it depends problem, but once you kind of lay it out and understand the timelines and the bottlenecks and the delays, you can look at it using either a capabilities-based model where you look at all the capabilities we've outlined, and you can even just ask your teams, like, what's your biggest bottle? What do you swear at all the time? If you have a dartboard, what's on your dartboard? Or you can use value stream mapping. That's a process-based, constraints-based model. You can use either one of those to just say, like, what's my biggest problem? Fix that, and then rinse and repeat.
Totally. Yeah, that makes a lot of sense. Kind of pick apart your own what's going on right now. Yeah.
Yep. Diagnose your own problems.
Mm-hmm.
And
thank you.
And the thing is, companies don't like that. It's really hard because they want to know what their 3-year plan is. But your 3-year plan, like, that's why consultants make so much money, because they sell everyone the same 3-year plan, or they have 3 different ones that they like just resell, and they like just do a find and replace on like the letterhead on the top. Right? Because it makes executives feel safe. It makes them feel secure. It's like they know what's happening. But the problem is, like, that 3-year plan is good for like the first 6 months, because like they matched on that first problem. But once you fix that part, you're working in complex distributed systems. And so things reshuffle and rechange. And then the rest of the 3-year plan doesn't match anymore. So what you need to do is like teach people how to diagnose their own problems, so that when it changes, they're like, oh, wait, I know how to do this. It's fine. It's like when you first start learning a new skill or working out or something, it's a little uncomfortable at first, but once you know it, you're fine. You know how to like do that next step.
Mm-hmm. Yeah, it seems like that. Yeah, that process needs to be checked all the time, constantly reflecting. Yeah.
Yep. Awesome. And once we know how to do that and guide people through it, we're super valuable.
Awesome. Thank you.
Mm-hmm. Yeah, thanks, Jordan. Thanks for that great question. I know Jordan is interested in being a program manager, right? And so this kind of thing is super.
Well, that's key.
Yeah, super. Yeah. Right. I'll switch. I'm going to just pick a couple more questions that have the higher number of votes here. So Rohith, do you want to ask? So we're sort of pivoting a little bit from thinking more organization, I think, to more the individual, right? Are you there, Rohith? Do you want to ask your question?
Yes. My question was, what are the metrics used while measuring a performance of an individual? I was mostly like, how do you measure performance?
How do you measure performance? So that depends on which performance you're measuring, right? So if we're measuring the performance of a software delivery system, that's going to be the DORA metrics, right? So speed and stability. And the reason those ones are so good is because you're capturing the two, or I guess I should say the outcome metrics, right? So 2 speed metrics, lead time and deployment frequency, and the 2 stability metrics, time to restore service and change fail rate. And those are nice because they're held in tension. It's kind of for the 2 teams that are historically opposed, or they have opposing goals and opposing interests. You can hunch them, right? Like you can ask someone how it's going. You can also use full telemetry for them. If you're thinking about organizational performance, you can think about historical, like financial metrics, or you can think about what that organization's users and customers care about. But it really is going to very much depend on what that organization does, and that will vary depending on what industry they're in. Are they financial services? Are they retail? Are they government not-for-profit? Are they education? What are their current goals? So the tricky thing is those need to be tailored.
I think, Rohith, in your question originally, you had put in the word individual. Did you mean at the level of the developer? Is that what you were interested in, or?
Yeah, I was thinking about particular person.
Oh, so individual performance. So individual performance, these are, Peggy, I'm working on a paper with Peggy right now. So this is also very, I'm gonna like summarize some of this work. So individual performance is something that is also sort of context dependent. And we wanna think about this in a similar way to what I just mentioned with software delivery. And by similar way, I mean, we want to think about an outcome. What are the goals? What are we thinking about? And we want to measure it in several ways. Because if you only measure one thing, that's going to like lead to bad outcomes, unintended consequences. So if we're thinking about software in particular, many times people talk about productivity. So if you're thinking about productivity, many people think about activity. Things like lines of code, although lines of code has problems, right? So like lots is bad because it gives you bloat and technical debt. Less is sometimes good. Sometimes the best thing you want to do is delete code. But if you write too few lines of code, then like no one can understand it. So typical activity metrics are going to be things like number of commits, pull requests. You can also do things like the amount of time that you've spent working. Not that you want to do that from a management perspective, but sometimes people like thinking about that because they work in like Pomodoro metrics, right? If you've ever heard of Pomodoros, it's a nice way to manage your own time, right? So you work for 5 or 10 minutes, and then you have like 5 minutes off, or 10 or 15 minutes on, 5 minutes off. You can also think about things like satisfaction and productivity, or sorry, satisfaction and well-being. Because that tends to be highly correlated. You could think about things like flow. So many times people talk about productivity in terms of the ability to get complex work tasks done with minimal distractions and interruptions. That can be a perceived metric. That can also be a metric that we capture with telemetry, which is like how long someone does something without being interrupted. Right, so there are a handful of things that we kind of capture. And you want to try to capture like at least 2 or 3 of those dimensions once.
Thanks. That was a great description of the framework. We're almost at the end. Well, actually, it's just 4:30.
Oh yeah, sorry.
Oh no, not sorry. Can I sneak one more in? Because Richard asked a bit of a follow-on that I think you might like. Is Richard still in the call?
I am.
Yeah.
Go for it.
I wanted to ask, like, if you think that some of these high performance teams are actually more susceptible or less susceptible to burnout than like their low performing counterparts, and whether or not DevOps might help reduce that.
I love this question. I think this is a perfect one to end on. There are a few things to mention here. One is that I think anyone is susceptible to burnout. I think in many ways, high performance teams will be less susceptible to burnout. And we do find that many of the capabilities and practices that are predictive of high performance are just as, or I will say, are also predictive of decreases in burnout. Something that is very interesting to note is that DevOps was originally started as a movement to create more humane and more sustainable software delivery practices. It was originally started, the name of it was, the suggested name of it was Agile System Administration. So Agile had started as a way to increase collaboration and increase matchup between business and development, which means that development was doing a whole bunch more work and was throwing a bunch of software over the proverbial wall, and it was just burning out ops. Ops was just tragically burning out. And so DevOps started as a way to try to find ways to make that software delivery pipeline extend end to end from dev all the way through to ops, to not just make software better, but to make the entire software delivery pipeline and process better, smoother, and most importantly, more humane. because the ops side of the ops folks side of the process were sick of like dying, and the dev folks who saw it happen didn't like what they were doing to their peers and their colleagues. And so what we see is that by breaking work into smaller pieces, delivering smaller pieces more often, more frequently, what we end up doing, and doing it collaboratively, is we're delivering software in smaller pieces. We understand what's happening end to end. We're building software that's meant to be scalable. We're building infrastructure that has high performance capabilities and processes. And by developing it and delivering it in small pieces, it has a smaller blast radius. It has lower likelihood of failure. When it does fail, it's much easier for us to debug and understand what happened and how we can fix it. Although also, Burnout right now, like we're not working from home. We happen to be working from home in the middle of a pandemic and the world's on fire. So
Yeah.
Disclaimer 2020.
Yeah. Well, thank you so much, Nicole. I should probably let you go there. I'll put us in gallery view here for me, which you all can do as well. That was fantastic. Thank you so much for taking the time to join us today.